Enguage is a natural language understanding technology which can be integrated into products and services to provide an accessible vocal user experience. In this presentation, we are going to look at the process which Enguage goes through to act based on a user's intent and to create an appropriate response. Enguage is designed to take input primarily from vocal speech-to-text services provided by operating systems. For this presentation, we are going to imagine that the user tells Enguage that James needs eggs because he is baking a cake. This input is called an utterance, and we're going to see what Enguage does with that. The commands for a given utterance are stored in the repertoires which we provide Enguage with. These repertoires are text files held within the concepts folder and are named after the linguistic concept that they contain. So when Enguage reads our utterance, it knows that it must load the need and needs and the why and because repertoires to find correct interpretations for the utterances. Let's look at the contents of these two repertoires. Here we see the first few lines of the two repertoires, because on the left and needs on the right. Enguage finds one matching interpretation in each repertoire. Let's have a look at these in more detail. The first line of each interpretation contains a pattern which Enguage looks for in the utterance. Uppercase blue words in the pattern represent variables which could represent any string of words. For example, in the first interpretation, what has a value of James needs eggs, and in the second interpretation, subject has the value of James. The lowercase green words represent string literals, which must be identical in the utterance and in the pattern. We can see that some of the variables have prefixes or suffixes, which tell Enguage what type of data it should expect for that variable. Enguage orders all available interpretations by their utterance pattern complexity, which is a measure of the ratio of the size of the variables in the utterance to the size of the string literals. This means that very specific interpretations are dealt with first, which finds the desired interpretation more often than not. If Enguage misinterprets an utterance the first time, a user can simply say no and then repeat the same utterance for Enguage to give the second interpretation. Let's look at the chosen interpretation in more detail. We can see that the interpretations have the general form with the pattern at the top, actions to complete in the middle, presented in a semicolon list, and then a reply to the user at the bottom. Let's see what this specific interpretation does. First, Enguage interprets the meaning of cause, i.e. interprets he is baking a cake, by treating cause as another utterance, accessing further repertoires. If Enguage fails to interpret the meaning of cause, it will end the main interpretation by replying, I do not think he's baking a cake. Next, Enguage interprets the meaning of what, i.e. interprets James needs eggs, by treating what as another utterance and accessing further repertoires. If this fails, then Enguage will end the main utterance with a reply, I do not think that James needs eggs. If Enguage understands what and cause, it will then go on to access a method to create an XML list called why because to store the what and the cause for future use. Finally, Enguage replies, OK, James needs eggs because he is baking a cake. This is to tell the user that the interpretation has been found. These interpretations can be written to complete any task needed by a service. Interpretations can perform functions, run programs, and send and receive data through the internet. Let's see how a conversation might play out. James needs eggs because he is baking a cake. Enguage goes to its repertoires and finds two interpretations. It selects the correct one and gives us a response. The conversation could continue as follows, where Enguage accesses further repertoires to find the correct interpretation.